STA 3624 Time Series Analysis and Forecasting. Lesson 2, Time Series Analysis. In previous lesson we discussed about the introduction to time series analysis and forecasting and the components of the time series. Now we are going to identify how to apply the time series models. So to apply a time series model, first we have to remove the variations. That means that variation means we discussed in the previous lesson that trend components, cyclic components, seasonal variation and the irregular fluctuations and unconstant variances we have to remove. Then only we can apply the time series models. Then the time series models helps to predict the future values. So before applying the time series models, we have to remove these variations first. And a general approach to time series modeling. So this is the approach. Plot the series and examine the main features of the graph, checking in particular if there is a trend, seasonal component, any apparent sharp changes in behavior, any outline observations. First you have to plot the graph and you have to check is there seasonal component or the trend or the sharp changes. First thing is that. Then secondly, remove the trend and the other components. It means you have to remove the variations as I explained in earlier. Choose the model to fit the residuals. Then next you have to choose the model, and finally forecast will be achieved by forecasting the residuals. So by forecasting the residuals we can do the predictions. Then there are two types of time series models, stationary time series and non-stationary time series model. A stationary time series is one whose statistical properties such as mean, variance, autocorrelation and etc. all are constant over time. So if we take the stationary time series, all these statistical properties, that means, variance, autocorrelation, autovariance, all are same. It means no trend, no seasonal variations, no cyclic factors and constant variable. Then that if a time series model is hold these properties, we can tell that is a stationary time series. And transformation of non-stationary time series into the stationary time series. So if you observed non-stationary time series model, so it means is there any trend, seasonal factors or the other variations. First you have to remove those variations by using box-Jennings methods or the classical methods. Then you can convert into that non-stationary time series for the stationary time series. Then find a suitable probability model to represent the time series data, and finally predict the future values. If you have the non-stationary time series, you have to remove these variations and convert into the stationary time series. Then you can do the predictions. Then stationary time series can be classified as strictly stationary time series and the weakly stationary time series. Most of we are dealing with the stationary weakly stationary time series models, right? Strictly stationary time series model means a time series xt t equal 0 plus or minus 1 is said to be strictly stationary. It has a stationary property similar to those time shifted series t plus h t equals 0 plus or minus 1 so on for each integer of h. So if time is shifted, it means if we have a time called xt1, right? Here if we shifted x t1 plus h, h means when h equals 0, what is it? X t1 plus 0, because h equals 0, then it is x t1, right? Then when h equals 1, that is x t1 plus 1. Okay, so then if we time shifted, then properties are same. It means if you take mean, they and the other statistical properties, they are not vary. If it is not vary, that is a strictly stationary time series. Okay, that is the idea of the strictly stationary time series. But we are normally dealing with the weakly stationary time series. A weakly stationary time series is defined as one which imposes condition only one on the first two moments of the time series. If that is a weakly stationary time series, it holds these two conditions. The mean value of function, that means mu t, is constant. Mu t is constant and does not depend on, here depend, this does not depend on time t, right? So that first condition is mean value of mu t is same, then it is independent of time t. So first we have to, if we have to show that given time series is a stationary one, then first you have to show mu t is constant and it is independent of t. And second property is the autocovariance and covariation function gamma s comma t does not depend on time. That is also does not depend on time. It depends only on the difference we normally call lag h, which is modulus s minus t. That is only depend on this lag. So if these two conditions are hold, that means that is a weakly stationary time series. Normally we are taking stationary time series as the weakly stationary time series. We are solving problems related to the weakly stationary time series, not related to the strictly stationary time series. So given problem is given to show that process is stationary, so you have to use these two conditions, and so and finally if these two conditions are hold, you can write the given time series is stationary time series. And this is the autocovariance function. So we are going to obtain the equations to solve the problems. So here you can see that is xt and this graph between xt and t. So 2 points on the same series observed different times, then time if t equals t, then you can take xt there. If t equals s, you can take xs. These are the 2 points in observed from this time series histogram. Assuming two values xs and xt are jointly distributed random variables with the function f of xs xt. Then autocovariance function is defined. So this is defined the second moment product. So autocovariance function is defined like this. So you have to remember these functions. Gamma s comma t equals gamma h. H means this one, this h. Yeah, this h. That is equals s minus t. Right? Gamma here s minus t means h equals s minus t according to the definition. Right? Gamma s minus t. Then that is equals to the covariance of xs and xt, right? Covariance of xs and xt equals, so you know that to find the variance here, if it is given variance, how we can find? Like by using this equation, right? So then here that covariance you can write xs minus mu s, since mu s is mu s and mu t are the means of these processes. Then xs minus mu s times xt minus mu t, and by simplifying this you can take this equation also. You need to remember this one, and also this one or this one to solve these problems, right? So you have to keep these things in your mind, right? Then here, when x equals t, s equals t in here, so what we'll see what happen when s equals t. So this one, gamma s comma t, then it's became s equals t, then gamma s comma s, or you can write gamma t comma t, because s equals t. Instead of s you can write t, instead of t you can write s, because these two are equal. That's why we are written there. Then what happened? Then here xt, again this t equal s, then it's become xs, right? So again you can substitute the xs minus mu s, then xx minus mu t. So if you take mu equals mu s equals mu t, right, then you can write this is the variance, so you can write e xs minus mu square. Then when 2 points are equal, then the autocovariance function equal to the variance, right? If t equals s, then the autocovariance automatically converted into the variance, like this way, right? So you can that just understand what is happening in the equations. When you are solving the problems, you can understand how to use these variances and autocovariances. At the beginning, try to understand what happened in the equations. That is enough. Then when we are doing the examples, exactly you can understand how we can deal with these equations, how to. Then here remember that when t equals s, that is covariance is automatically converted into the variance, right? Sometimes in the questions variance are given, so if you have to use the variance in at that point, if after simplifying to that point, then you can find the variance, then you can substitute the variance and find the final answer. And this one you learned in previous subjects. Anyhow, I am going to revise this again. Variance is a special case of the covariance when two variables are identical, right? Normally mu, that mean we are taking expectation of x, mu equals ex, and variance of x equals covariance of x and x, right? That's why we are using in here also. And variance of x minus mu, here also you can write x minus mu, then it means variance equals x minus mu square. And you can simplify and take this equation ex square minus ex whole square. This equation and these equations are useful when we are solving the problems. Right, now we will move to the example 1. Right, find the autocovariance and covariance function of wt which is uncorrelated, and has zero mean. Show that process is stationary, and here mean is 0 and variance is sigma w square, right? So you have to identify these things first. Here mean is 0 and variance is sigma w square. Variance is sigma w square. And there is another special thing you have to remember: wt is uncorrelated. That is uncorrelated, right? So first thing is according to these conditions, right? So first you have to show the mu t is constant from the independent from the time, that is does not depend on the time, right? First thing is you have to show, right? First we have to show mu t is independent of time t. That is, first we have to do time t. So mu t, so how we can find mu t? By using this expectation of, right, that is expectation. Mu t means expectation of w t, right. Then mu t equals expectation of w t, that is given 0 mean, no, that w t has 0 mean, it means mu t is 0. Then mean of this process is equals to 0. Then that is not include the time, terms in t, it means that is independent of time t, right. Therefore we can write mu t is a constant. 0 means that is constant and independent of time t, right. Now first property is correct, no. Now we are going to show that is a stationary process, no, right. Then first property is this one, the mean value function mu t is constant and does not depend on time t. Now we found that is constant, yes, and independent of time t. Then first condition is fulfilled. So now we have to consider about the second condition. It means what is the second condition? The autocovariance function is does not depend on time and depend only the difference of the time. Okay, so then second property we need to find, insert, right. So now we are going to find the autocovariance functions, right, autocovariance functions. Right, autocovariance function. Now we have to find autocovariance function, right. So we can find the autocovariance function, that is gamma s comma t, we named as gamma h, right. So according to this one, yeah, here gamma s comma t, gamma h equals, then we can write covariance of xx comma st. Then we can write difference of these two, no, right. I am going to now write these steps according to our example, right. Then I can write that is covariance of ws comma wt. Now we have w, here w, no, then ws comma wt. Then according to this we can write expectation of ws minus mu s, then wt minus mu t, right. then I am going to write expectation of ws minus mu s wt minus mu t. But here given what mu equals, we found that mu t and mu s are equals 0, right? So but mu t equals mu s equals 0, therefore we can write gamma s comma t equals expectation of ws subtraction mu s equals 0, wt subtraction again mu t also equals 0, right? So expectation of here remaining ws minus 0 means ws, wt minus 0 means wt. Okay, now we got the function gamma s comma t equals expectation of ws comma wt. And now here then we have to find what happen when s equals t and what happen when s not equals t. Now we are going to process this part in our example. Okay, now then I am going to find, we know that according to the theory s minus t equals, we have to take x minus t equals h we are calling as lag, right? Now we suppose when s equals t, so we can write h equals s minus s here, h equals s equals t, or we can take t minus t also, right? Anyhow, then instead of s we can write t, instead of t we can write s, that is 0. It means h equals 0, right? H equals 0. H equals 0, right? Then now h equals 0, then we can write gamma s comma t, we are normally taking gamma h means h equals 0, we can write gamma 0. Before that, if you like, you can write gamma h also here, gamma h, then h equals 0, then gamma 0 equals gamma 0 equals this one, e ws. Now s equals t or t equal h. Now instead of t we can write s, no? Or if you like, you can write e, t and s are equal, so wt, no? Instead of s you can write t, instead of t you can write s, because t and s are equal now. Okay, so what is this? This is variance, right? wt means variance in, according to this one, no? Here if it's come 2 times one thing, it auto-k variance equal to the variance. So now here comes, then gamma 0 equals variance, right? What is variance in this question? It is given, that is sigma w square. So you can write the answer here, sigma w square. right? Then now we found the case which is s equals t. Then I am going to consider the next case when s not equals t. S not equals t. The other case is s not equals t. When s not equals t, what we have to do? Again the same thing, gamma s comma t, same equation. Then gamma h. What happened there? Here come this one, no? Now s not equal t, then sigma ws comma wt. But here there is a statement, its word is given uncorrelated. Uncorrelated means if this one ws, if these two are different, s and t comes, what happen? Uncorrelated means this part equals to the 0, right? Since they are uncorrelated, if there is term like this s and t or x and y or the two different letters, it means that part is 0. Then it means this one is equals to the 0, right? So this thing you have to remember. Two real valued random variables are said to be uncorrelated if their covariance is 0. Okay, so then uncorrelated, it is given uncorrelated, it means the covariance equals 0. You have to remember this statement. That is helpful for simplify by the simplification of problems, right? So here we can take that is 0. Now we can take the autocovariance function. It has two parts. We can write, therefore the autocovariance function can be written as gamma s comma t. It has two parts. We took two answers here. Sigma w square if h equals 0, no? H equals 0 and 0. Here comes 0, that is otherwise. So this is the answer. So autocovariance function, that is sigma w square, that is h equals 0. Then if h not equals 0, that is come 0. Then here there is no t terms. It means therefore autocovariance function is independent of time. Now earlier we found that is mu t is constant and independent of time t. It means mean, and also autocovariance function is also independent from time t. Then according to the conditions, then two conditions are fulfilled. It means, that means therefore wt is wt process is wt process is stationary, right? That is the complete way of showing a given process is stationary. What are the steps? First you have to find the mean, then you have to show mu t is constant and independent from time t, then you have to take the autocovariance function, then you have to consider the s equals t and s not equals t, and you have to show this is independent of time t. Then both conditions are fulfilled, that means that is a stationary process.